Software architecture. Let's look into the main definition of it. What is the software architecture and why it is important? So to create a reliable, secure, and efficient product, we should always pay attention to the architectural design. And what are those architectural design aspects? So it's mm, mostly about the overall organization of the product, then how the software is decomposed into different components, what is the organization, what is the server organization, and what technologies you are using to build the software. And so the architecture mostly affects the performance, security, reliability, and other aspects. And so let's look into uh, the IEEE definition of the software architecture. It's basically same thing that I just mentioned about as per the IEEE standard, so which is the most recognized standard for the research and development. So as per IEEE, the definition of software is basically is to create the reliable or efficient product, and by taking into considerations of various aspects such as the overall organization of the software, or what are the different components to which it need to be decomposed, and what technologies, or what technologies you are using for building the software, or what is the server organization. See, software architecture and components. So when designing software architecture, you don't have to decide how an architectural element or component is to be implemented. Rather, you will pay attention to the design of component interface, and leave the implementation of that interface to a later stage um, of the development process. Let's look into um, this figure, um, which gives us an architecture of software components, how they are related to each other. So the best way to think of a software component is as a collection of one or more services that may be used by other components. So these are three different components, multiple components, and services are accessed directly using all these components. Um, all the services are accessed directly by the other components. So a service is actually a coherent fragment of functionality, and it can range from a large scale service. So it may be a database service or a microservice, so which doesn't very specific, which does one of very specifically one thing, certain type of a thing, that is your microservice. So one example could be just simply to check the validity of a URL. Okay. And the more about it will be discussed in the advanced chapters in this course. So sometimes the services which are accessed through the, in the component, they could also be accessed using the API. So API is an application programming interface which enables the companies to open up their applications data and functionality to external third party developers, business partners, or internal departments within that company. And this allows the services and products to communicate with each other and leverage each other's data and functionality through a documented interface. So more details about the API, you can follow the links here that I provided. What is an API? So just go through the links and get more understanding about the API and how they are being deployed with various services. These are the two helpful links. It's under your activity overview section. And it also explains about how what is the working structure of the API. Everything is can be accessible through all those two links that I provided. Now let's see why architecture is important. So let me take you to this table. Okay, here it is. So the table 4.2. So why architecture is important? There are some attributes, non-functional system quality attributes. So these are the attributes. These basically explain why the architecture is mostly important. So architecture is important because the architecture of a system has a fundamental influence on all the non-functional system quality attributes or properties, which is seen here in this table 4.2. And the design, architectural design, basically involves understanding the issues that affect the architecture of your product, and creating a description that shows critical components and their relationships in the system. So, the responsiveness, reliability, availability, security, usability, maintainability. So, these are some of the key issues or the quality attributes which mainly add on to the importance of the software architecture. So, architecture. Um, so, Uh, so architectural design, it mostly involves the understanding of the issues that can affect the architecture of your product, and creating an architectural description can shows the critical components and relationships, and minimizing the complexity could be an important goal of your architectural designer. So if you have a more complex system, then the to understand and to change the system, it can be more difficult and expensive too. So programmers are more likely to make mistakes and introduce bugs or security vulnerabilities when they are modifying or extending a complex system. Just look into the different aspects and what are they actually referring to, and how they are related to the architectural design aspect. Here is one example provided in this table 4.3, the influence of architecture. Let me minimize it to look into the whole thing, to the total example. So it's an example of a centralized security architecture. You could read the whole example here. So if you see this example, so it actually explains about why architecture is important, and how the architecture of a system has a fundamental influence on all the non-functional properties that we just seen in the previous slide. So this example here is a non-computing example of how the architectural choices can affect the system properties. So what architectural choices it has adopted here? So this example is taken from the film Rogue One. It's a part of the Star Wars saga, and the centralized security architecture are easy to design and build. Protection and protected information can be accessed efficiently. So this is the thing that is explained here through this example. And while it has used the centralized security architecture, however, it can also um, if there is a situation, if your security is breached, so and everything is stored in a centralized shared space, then you could lose everything. But if you distribute the information, it takes longer to access all the information, and costs more to protect it too. So if your security is breached, or compromised in one location, so you will lose only the information that you have stored there. So based on the situation, you have to consider where you can consider a centralized security architecture and where you can adopt a distributed security architecture. So the more explanation is provided here in the, you can look into this slide and also the related information in the book as well. Okay, so let's see the maintainability and performance. So how it explains the architecture by taking into consideration the different um, components here. So this is an example of a shared database architecture. So this figure here, it shows a system with two components, C1, C2, and it shares a common database, shared database. So if we assume that the C1 runs slowly because it has to reorganize the information in the database before using it, and the only way to make the C1 faster might be to change the database. Okay, that there might be some change which is needed in the database. So it means that C2 also has to be changed, and which may potentially affect its response time as well. Whereas here in this figure 4.3 in the multi-database architecture, so it's a different type of architecture, and it's used where each component has its own copy of the parts of the database that it needs. It's actually there's two figures here. This is actually referring to your example, this one that we just saw. uh, this example here, centralized security architecture of the ROG one. So we are just looking into the architecture of a centralized database architecture where the database is shared, and a distributed database architecture where each component has a unique copy, uh, its own copy in its own database. So here, if one component needs to change the database organization, this will not affect the other component. So if C1 need to change the database organization of its own, so it will just go into C1 database and change it there. It doesn't have to do anything with the C2. So here C2 totally remains untouched. Okay. So it's more feasible to have this type of architecture. Uh, but there can be some situations where the multi-database architecture may run more slowly and may cost more to implement and change. So a multi-database architecture needs a mechanism, a component C3 to ensure that the data here, this picture here, C3, so it ensures that the data shared by C1, C2 is kept consistent when it is changed. Okay. Okay. Well, so let's see the issues that can influence the architectural decisions. Uh, give me a moment. So the non-functional product characteristics, software compatibility, number of users, software reuse, product lifetime. So these are some of the issues that can influence the architectural decisions. So what is this non-functional product characteristics? So it can refer to the security and performance effect of all users. So if you get this wrong, your product is unlikely to be a commercial success. So unfortunately some characteristics are opposing, so you can optimize only the most important. So product lifetime, if you anticipate a long product lifetime, you need to create a regular product revision. So you therefore need an architecture that can evolve so that it can be adapted to accommodate new features and technology. Then comes software reuse. So here you can save a lot of time and effort if you can reuse large components from other products or open source software. But however, this can constrain your architectural choices because you must fit your design around the software which is supposed to be reused. Number of users. So if you are developing customer software delivered over internet, the number of users can change very quickly. Okay, and this can lead to serious performance degradation unless you design your architecture so that your system can be quickly scaled up on and down. Hope you can relate to this scenario. Then software compatibility. So for certain products, it is important to maintain the compatibility with other software so that the users can adopt to your product and use the data prepared using a different system. So here, these are all the issues and their explanation. Related examples also could be found from the book as well. A trade-off between the maintainability and the performance. Let's see the slide, this one here. Okay. So architectural design involves considering all the issues that are discussed and deciding the essential compromises that can allow you to create a system that is good enough and can be delivered on time and within a fixed budget. So system. So here we are going to discuss various trade-offs when choosing an architecture for a system, for a new system. So system maintainability is something which can reflect on how difficult and expensive it is to make changes to the system after it has been released to the customers. Okay, so you can improve the maintainability of while building a system from a small from different smaller parts, each of which it could be replaced or enhanced if changes are required. But in architectural terms, it means that the system should be decomposed into multiple fragments or components, each of which should actually do one thing and one thing only, just specific thing. If every component has its own specification or functionality, it is good for the system. Here, let's look into while discussing about the trade-off in between the security and usability. This is the figure about the authentication layers. So we just saw the trade-off between the maintainability and performance aspect of the system while while working on the software architecture. What is the trade-off or relation between the security and the usability? So there are different authentication layers: IP authentication, application, feature, encryption. Okay. So you can achieve the security by designing the system protection as a series of layers as shown here in this figure. So an attacker has to penetrate all those set of layers before the system is compromised. Okay. So here there may be a protected asset such as a user's credit card. So there are so many, and if that credit card is used for some type of purchase, then if someone is about to hack that, they have to go through all these layers. So this layers of protection are very important for the system security aspect. And as I just mentioned, the layers might include the system authentication layers. You know, in addition to this, it can also include system authentication layer, separate critical feature authentication layer, various other layers as well. So architecturally, you can implement all these layers as separate components so that if one of the component is compromised by an attacker, then the other layers can remain intact. Okay. Let's see what are the usability issues. Okay. So we just saw the layered approach for the software security aspect. So users have to remember certain type of information such as password, which is needed to penetrate. Maybe this is your security layer, some type of security layer, and their interaction with the system is inevitably slowed down by this security feature. So many users can find this irritating and often look for workarounds so that they do not have to re-authenticate the to access the system features or the data. So but to how to avoid this, so this thing is explained here. To avoid this, you need to you need to incorporate all these things in your architecture. So need to ensure that doesn't have too many security layers, that doesn't enforce the unnecessary security, which whatever is important, just implement them. Anything unnecessary, do not include them, just discard. And which can also provide helper components that can reduce the load on the users. These are various usability issues. To avoid the issues, you need to consider all these aspects. Then the trade-off between availability versus time to market. So the availability of a system is a measure of the amount of uptime for that system. So availability is normally expressed as a percentage of time that the system is available to deliver the user service. So architecturally, you achieve the availability by having redundant components in a system. So to make the use of redundancy, you include the sensor components that can detect the failure and switching components that switch operation to a redundant component when a failure is detected. But sometimes implementing the extra components also takes time and increases the cost of the development, and it can add complexity to the system and also increases the chances of introduction of bugs or vulnerabilities in the system. These are some of the architectural design questions. You can see that how the system should be organized, what components, architectural components could be taken into considerations, how these components can provide usability for different functional system functionality, or how the system components could be distributed, how they communicate with each other, what technologies you should use. So these are some of the architectural design questions. Then comes component organization. Uh, so here is a figure given. Okay. It's a diagram for the document retrieval system. This is an architecture for that. So your component organization. Uh, so what happens at the architectural level? Your concern should be on a large scale architectural components And decomposition can involve analyzing the large scale components and representing them as a set of multiple finer grained components. And we just saw layered models are often used to illustrate how the system could compose of different components. Let's look into this figure here for the document retrieval system. So see, there are this is actually the diagram of the architecture of the product, the document retrieval system, and this system is designed for use in libraries and can give users access to documents that were stored in a number of private databases, maybe legal or patent databases. So each here each layer in the system includes a number of logically related components. So web browser, it has some logically related components such as user interaction, local input validation, local printing. Same way, here user interface management, it does have some multiple components. Same goes with other layers as well. So it shows how a system is decomposed into various components, with each component providing significant functionality. So in each layer, every component, so let's say user interface management, it has authentication, authorization. So it deals with all the aspects with the specific authentication policies. Then there is a form or query manager, basically will deal with the form or querying aspects. Or for web page generation, it basically deals with the web page generation aspect. So web page generation aspect doesn't deal with the functionality of the authentication or authorization, or nor the form or query manager. They have their unique functionality and they are handled with their unique component organization. Architectural complexity. Uh, so uh, complexity, that if there is a system architecture, there can be there can be various complexities if we are taking into consideration multiple components, the system architecture as a set of multiple components. So when decomposing the system into various components, we should try to avoid the unnecessary software complexity, such as the localizing relationship or reduced shared dependencies. So here, see, mm, in this figure, various examples of the component relationships are shown, where the C1 component is a part of C2. If the C1 can call or use some of the aspect of the C2. The C2 may use some of the aspect or the functionality of C1, or they can be located in one component together, or can share some sort of shared data among themselves. So if there are relationship in between the components, okay, the multiple components, then these are easier to understand if all the components are defined in the same module or in the same location. Whereas the reduced shared dependency tells this one, the reduced shared dependency. So if the components depend on some other component or data, third part or a third component, external component, in that case your complexity can increase, because changes to the shared component mean can mean that you have to understand how these changes can affect both A and B. This is a case of the last scenario. So it is always preferable to use the local data whenever possible, and to avoid the sharing of data if you can. Okay. So in this slide, it shows the architectural design guidelines. Um, separation of concerns, stable interfaces, implement one. So please read from the book and see and try to understand what these design guidelines are. And this is related to your, I'm not going into details of all this theory, the design guidelines, layered architecture, cross-cutting concerns. Okay. But basically using one example for looking into this aspect. Give me a moment. I'm trying to find out the slide to start here. Here, see in this figure, this is a layered architecture of a web-based application. Um, so for a web-based application, here the layers are shown in the figure, and it, in the figure can be the starting point of your decomposition process. So the first stage is to think about whether this 5 layer model is the right one, or whether you need more or fewer layers. Are all these layers, so one is your browser based or mobile user interface, next for authentication, for application functionality, basic shared services, and the transaction management. So whether these are the things which are only needed or required for the architecture, or do you need more layers? So your aim should be for layers which could be logically coherent, so that all the components can in the layer can have something in common. So it means that you need one or more additional layers for your application specific functionality. Sometimes you may also wish to have the authentication in a separate layer, and sometimes it makes sense to integrate the shared services layer with the database management layer. So depending on the situation and requirement, you can make changes to the various layers of the application in the software architecture. Its explanation is provided in this table here, the browser-based mobile user interface for that particular example, the web application, authentication and UI management or application-specific functionality, and the other two, basic shared services and the transaction management that I just mentioned about. Uh, now, um, in this example here, if you remember in the last class, we saw an example about the iLearn for different persons. We saw the user stories, other, if you remember, you could relate. So that iLearn architectural design is explained here, looked into its own aspects. Some explanation is given. Let me go into it. Okay, so you see in the island 30, okay, 36. This part is done. Okay. So in the iLearn design principle, iLearn architectural design principle, the various principles are all these: replaceability, extensibility, age appropriate, programmability, minimum one. So all these principles are somehow related in the examples that we have seen in the previous chapters. If you remember Jack, Elena case, Jack case, Elena case, Emma case, so they both, all of them were related to the iLearn system. So it's related to that. You could just read it if you don't remember particularly what where those case studies are examples. So here, these principles were thought to be most important when designing the island system. So the island system architecture, it could include all these principles. So our goal is to design this system to create an adaptable universal system that could be updated easily as new learning tools become available, or could be explored or introduced later on in future. So here, in the island system, there it must be possible to change and replace the components and services in the system. So it could relate to your replaceability and the extensibility principle here. Okay. So something related to the island design principle or the architecture. And then, because the potential system or the island system users, so it is used across various age ranges, starting with age 3 to 18, as per the island system explanation for various case studies of the Jack, Emma, and Elena's scenario. So here we needed to provide an age appropriate user interfaces and to make it easy to choose an interface. So it relates to this principle here, age appropriate principle here. Then comes the principle of programmability and minimum work. So this programmability principle could be related to the island system architecture, which can contribute to the system adaptability. And the principle 5, the minimum work, could be included to ensure that this adaptability will not certainly adversely affect the users who did not require it. Okay. Then designing the island system as the service oriented system. So this is an architectural layered model for the island system. Okay, we just saw the architecture layered model previously in the some one of the slide above. So this is a similar type of layered architecture model specifically for island system. So here what we will do, we have to consider the component in the system as a service, and these any of the service is replaceable, and new services can be created by combining the existing services. So every component in the system is a service and it can be replaceable. So if we look into the service integration, there are different types of service integrations. So here it is in this slide: full integration, partial integration, and independent. So full integration services, that means services are aware of and can communicate with other services through their application programming interface, APIs. The partial integration services may share service components and database, but are not aware of and cannot communicate directly with other application services, APIs. And the independent ones are the specific services which do not use any shared system services or databases, and they are unaware of any other services in the system, and they can be replaced by any other type of comparable service. Here in this layering structure of island system, each layer, as we saw in the previous slide also, each layer in the system can include a number of logically related components. Let's say user interface, it has web browser component and iLearn app. Then user interface management has four different components, each of them having unique functionality. So it shows how a system is decomposed into various components, with each component providing significant functionality. Next comes your distribution architecture. Okay, so what is this distribution architecture? Let's look into this client server architecture. Uh, so in distribution architecture, one of the example is your client server architecture, which is suited for applications where clients access the shared database and business logic operations on that data. So in this architecture here, the user interface is implemented on the user's own computer or mobile device, and functionality is distributed between the client and one or more server computers. So here this figure, it is a logical view of the client server architecture that is widely used in the web-based and mobile software products. And these applications include several servers such as web servers, or database servers, and it is designed to ensure that the computing load is evenly shared by the set of servers. Um, Here, the client is responsible for user interaction based on the data passed to or from the server. So, previously, actually, all processing were carried out on the server with a client handling only the user interaction. But now the clients are computers or mobile devices with lots of processing power. So most applications are designed to include significant client side processing also. Um, I can give you some of the examples of the client server architecture. You could relate to the mail servers. Some of you must be using the Gmail or Yahoo or Outlook. So all these email servers can be used for sending or receiving the emails. Correct. So this type of email handling servers, these are some of the examples of that. Or your file servers. So file servers are something which are the centralized location for the files. Let's take the example of cloud services for the Microsoft Office or your Google Docs, right? If you have used Google Docs, so all the files could be accessed from your devices, and files that you save from your computer will be accessed from your phone also. Okay. So in this way, the file stores will be centralized and accessed by multiple clients, whether it can be your computer or it can be your mobile device or something else. MVC, that is the Model View Controller System or Model View Controller Pattern. So MVC is a software design pattern commonly used for developing user interface that divide the related program logic into three different interconnected elements. So those three different interconnected elements are your model, your view, and the controller. And this is actually done to separate the internal representation of information from the ways the information is presented to and accepted from the user. So the model here is the central component of the pattern. It is the application's dynamic data structure. And your view is any representation of information, such as it can be a chart, a diagram, or a table. And the controller segment can accept input and convert it into the comments for the model or the view. Um, so traditionally, This type of architecture is used for the graphical user interfaces, and this pattern has become very popular for designing the web application. So popular programming languages nowadays have the MVC framework that can facilitate the implementation of the pattern. So your Java programming does have a MVC framework, model view controller framework. As we are looking into the client server architecture, let's understand some concepts about the client server communication. So, you may have seen in your URL most of the time using the HTTP protocol. So, at some point of time, uh, we do not have, I don't know, yeah, we do not have a networking topic or course right now. So in computer in future, you may have read about it, or if in future you will take the computer networking course, then you will learn more about it. Different type, there are various types of protocols like HTTP. Okay. So client server communication normally uses the HTTP protocol. So based on this protocol, what happens? The client sends a message to the server that includes an instruction, um, such as, there are different type of instruction, get or post instruction. I'm not going into details about that. So when the client sends the message to the server with an instruction, it actually sends it along with a identifier of a resource, usually your URL, uniform resource locator, on which the instruction should operate. When you see a web address, you could see HTTP, then www, then Google, then .com for the google.com web page. So something like that. Your HTTP protocol is a text only protocol. So structured data has to be represented as a text. And there are two ways of representing the data that can be widely used, and they are your XML and JSON. So XML is a markup language with tags used to identify each data item. If you have taken web development, you could relate to it. You may have came across the XML. And the JSON is a simpler representation based on the representation of objects in a JavaScript language. If you are interested, please look into some, mm, you can just Google it, search it, and get more details about the HTTP protocol and how it plays such a bigger role in your client server communication. Here in the figure, it shows a multi-tier client server architecture. So there are multiple clients and a web server. Web-based applications usually include three types of servers mostly. A web server that communicates with clients using HTTP protocol. It delivers web pages to the browser for rendering and processes the HTTP requests from the client. Then an application server is responsible for application specific operations. Let's say booking system for a theater, right? The application server provides information about the shows as well as basic functionality that allows um, um, an interface to book the seats for the shows. Then the database server, it can manage the system data and transfers this data to or from the system database where the data is stored actually. Next is your service oriented architecture. So formally, your service oriented architecture is an architectural approach in which applications make use of services available in the network. In this architecture, services are provided to form applications through a network call over the internet. And it uses common communication standards to speed up and streamline the service integration in the applications. So, SOA, or the service oriented architecture, can allow the users to combine a large number of facilities from existing services to form applications. It can also encompass a set of design principles that structure the system development, and it does have the computing packages functionalities, which can be integrated into different software systems belonging to separate business domains. Then the different issues in the architectural choice, such as data type or data updates, the changes, the frequency changes, such as if you anticipate the system components to be regularly changed or replaced, then isolating the components as several services simplifies those changes. Then the system execution platform. If you plan to run your system on a cloud with users accessing it over internet, it is usually best to implement it as a service oriented architecture because scaling the system is simpler. Okay. So you must have seen, you must have used some sort of application where you can run your system or code in the cloud. There is an option for Python programming. There are various types of libraries. You have seen the data visualization. If you have taken the Python course, data visualization, there are multiple libraries. You can just use the cloud application for the Python. It looks like the Jupyter notebook application actually. Okay. So you do not have to install Jupyter notebook, just using your credentials, use that application provided in the cloud, and you can just directly run your code from there. Next, we are moving closely towards the end of our chapter, technology choices. Uh, so as we are dealing with the architectural aspect, so what technology choices we need to consider while making a decision about the design. These are some of the technology choices. So database. Actually, there are two kinds of database that are mostly used right now: the relational database and the NoSQL database. So relational database, you already know, so where the data is organized into structured tables, and the NoSQL database is something in which the data has more flexible and user defined organization. So relational databases such as MySQL are particularly suitable for situations where you need transaction management and the data structure that are predictable and fairly simple. Okay. But your NoSQL databases, there is a NoSQL database name is MongoDB, which is more flexible and potentially more efficient than relational databases for data analysis. Okay. Your Facebook uses the NoSQL database structure. Okay. Because it deals with such vast amount of data. Then your platform, delivery platform. So the delivery can be web-based or mobile product or both. So there are certain issues associated with it, mobile issues. So you can have intermediate connectivity, and you must be able to provide a limited service without the network connectivity. Okay. So then Another type of mobile issues is power management. So mobile battery life is limited. So you should try to minimize the power used by your application. Okay. Then to deal with these type of differences, you usually need a separate browser-based and mobile version of your product in the front end. So you may need to completely different decomposition architecture in all the different versions to ensure to have a proper effective performance and also all the characteristics to be maintained properly. Then your server, technology choice server. So a key decision that you have to make is whether your design system is to run on customer servers or to run in cloud. Okay. So for consumer products that are not simply mobile apps, so it almost makes sense to develop it for the cloud. Okay. There are certain business products which are it is more for business product it can be more difficult decision for choosing, like some businesses which are more concerned about the cloud security and prefer to run their system in in-house server, so they may have a predictable pattern of system usage, so there is a less need to design your system to cope with large changes in demand. Okay. So are you going to have in-house servers to run your application, or you are going to run it through the public cloud? That you need to make a decision about. Then open source technology choice. So open source software is a software that is available freely, you all know that, and which you can change and modify as you wish. So here the advantage is that you can reuse rather than implement a new software, which reduces the development cost and time to market. And disadvantage of using the open source software is that you are constrained by the software and have no control over its evolution. If it's going to be changed, then it will be changed, and you won't be able to concern about it, or you cannot do anything. You have to adopt to the new product evolvement. So decision on the use of open source software, you also depends on availability, maturity, and continuing support of the open source component. Mm. So your choice of open source software should depend on the type of product that you are developing. Your target, what is your target market, and what type of expertise does your development team have actually. So based on all those scenarios, you have to make the decision about the open source choice for your architecture. Then last is your development tools. So development technologies such as your mobile development toolkit, uh, your mobile development toolkit, or a web application framework, it can influence the architecture of your software. So these technologies have some assumption about the system architectures, and you have to conform to these assumptions to use the development system. And the development technology that you could use may also have a direct influence on the system architecture as well. So developers usually favor those type of architecture choices that use familiar technologies that they understand. So if we can take an example, so if your teammates have a lot of experience about the relational database, and they do not have that much expertise in the NoSQL database such as MongoDB, they will prefer and may argue for adopting the relational database rather than the NoSQL database. Okay, so these are some of the choices about the database delivery platform, server, open source, and development tools while working for your software design or software architecture. You can look into more details about it. Yeah, that's all. And with this, we completed this chapter. Yeah, I think the key points are there to the last. Okay, so let's move to the assignment part. So here, see one thing. mm, I have included the software estimation part with this. So software estimation is very important. If we are dealing or working on the software architecture, we must consider into software estimation as well. So before starting the development, um, before moving to the development phase, the estimation of the software will be done. So what type of what platform you are using, what technology where you are using, what type of database you are going to use, so all those details. So based on that, how much manpower is needed, okay, how much resource is needed, everything is needed to be estimated properly. So here, discussion you need to do, here is the discussion, why estimate software, and there is a test in this. Due dates are posted. um, then after reading the chapter, see the PowerPoint, and also read the content from the book as well, which will help you for attempting the test. And there are two links provided here. One from the guru99.com and another one from the software testing help. So please look into these two links, read thoroughly about the software test estimation, various techniques, what details, some examples. So from this, gather information or knowledge about the software estimation and apply that to participate in this why estimate software participation, discussion board. Okay, does it make sense? This is something new for you, which is not actually covered in the PPT. This is a homework for you. You need to just go into the links provided, details about the software estimation, and pose your points or explain about it in the discussion board. If you have any questions, let me know.